Express is one of the most important library for backend development in Node.js. You know why? Because it makes your backend code so easy to develop. Also, many big companies like Netflix and Uber use Express in their backend. And another big reason is it is a part of MERN and main stack. This E represent as Express.Js. So here is the Express.Js crash course in which you will learn how to create RESTful APIs like get, post, put, patch and delete. In short, all CRUD APIs. After that, you will learn how to validate the data, sending errors, returning proper status code like 404 not found, 201 for success, etc. Also, additionally you will learn about middlewares and how to create own middlewares in Express, which is very helpful and advanced concept. Also, you will learn much more about Express. So after completing this crash course, you will get clarity and confidence for using Express. You will learn all these things step by step, so everything will clear to you and you can understand Express in details. So let's start with building RESTful APIs. But before that, do you know what is the difference between simple API and RESTful API? Let's quickly see that first. Now, as we know, API stands for Application Programming Interface, and it is the way for two programs communicate with each other. In simple words, API is used to transfer data between frontend to backend and backend to frontend. We already know that, right? Now you might ask, what is REST API? So REST API stands for Representational State Transfer API. REST API is a specific way of building our simple APIs. Don't worry about its name, it's very simple. So REST API is the same API, but we have to follow some rules to build that API. If we follow some rules, that simple API becomes REST API. Now let's see some rules which we have to follow to make REST API. One rule is we have to define separate API URL for each piece of data. For example, suppose we are creating API for user-related operations like register a user, getting the information of single user, etc. In this case, our API should be our domain name and then /user for register. And if we want to get information about single user, then we create API URL like /user/123. Here, 123 is a user unique ID. Same as if we create API related to products, then our URL should be like this: /products/123/products/add to cart, etc. So by simply looking at this API URL, we get the basic idea related to our APIs, and by that we can easily do changes and our application stay clean. Another rule is different types of actions like reading, adding, updating or deleting data should use specific HTTP methods. Now you might ask, what are HTTP methods? So as we know, HTTP stands for Hypertext Transfer Protocol, and it allows our frontend to request and receive web pages and other resources from servers using API. So only because of HTTP we are able to send and receive data from backend using API. Now this HTTP has 5 main methods: get, post, put, patch and delete. Let me explain you this one by one. First one is the get method. We use get method when we want to only get data from the server. For example, we want to get all users details, or we want to get all products details, or we want to get single product detail. In this case, we define our API with get method. For understanding these methods, we will use analogy of library. So get method is like asking a librarian to show you a book or multiple books. Don't worry about implementation, we will see all methods step by step in this section. Second, we have post method. We use post method when we want to post or send some data from frontend to create a new data in our server. For example, for register a new user, we have to send user data from the front end and that will create a new data in our server. Think it's like we giving new book to librarian for add the book in library. Next we have put method. We use put method when we want to update an existing data on the server with new data. For example, if you change your profile information on a website and save it, then a put request is sent to update your profile with the new details. Think it's like giving librarian an updated version of a book to replace the old one. Next, we have patch method. We use patch method when we want to update a piece of small data, not entire data. For example, if we want to update just our email address in our profile without changing anything else, then a patch request can be used. Think it's like we are giving librarian just the updated pages of a book to update, rather than replace the whole book. Imagine here we have user object in our server. We want to complete this user object, then which method we will use? Right, we use put method. And if we want to update just the password of this user, then which method we will use? Right, we will use patch method. You are doing really great. So put method is used for whole data update and patch method is used for little update in the existing data. Now last method is delete. And you guessed correctly. We will use delete method for delete data from the server. For example, when we delete a post or a comment on social media, then a delete request is sent to remove it from the server. And for that, I don't think we need library analogy, right? And also, it is not practical. Think it's like asking librarian to remove a book from library. So you can see HTTP methods are very simple. We will use these 5 HTTP methods to define our different types of API. So these are just few rules we currently see, but don't worry, we will learn all these rules as we build APIs. Now you might ask why we need REST API, why we need to follow rules for building API. So by following any rules, we can make things organized. And that's true for REST API also. Rules will make our API more organized. Also, by following REST API rules, we create a simple and easy to use API because they use specific HTTP methods for doing specific types of work. Also, with rules, we can create a clean and maintainable API which any developers can understand and start working on them. For now, don't worry about rules. As I said, you will learn these rules while you create APIs. So let's start building our first Node.js project. I am very excited and I know you are too. Now before we start any project, it's better to roughly plan about that project. So as we know, our first project is about managing the task. And here how its front end looks like. Also, this is the first project of my React.js course. And we will build this project backend as our first backend project. Don't worry, we are not going to create here front end because our main focus is on the Node.js and building the best backend for our applications. From the front end, we just need to call APIs. Now you might ask, how can we plan Node.js project? It is very simple. This is the method I used for planning my backend project, even big projects. Instead of building project first and then doing major modifications, it's better to spend little time on planning before we start our project. So for backend project, if we create a list of APIs, that's very useful because backend is almost all about APIs. So for this project, first we need the list of all to-dos. So one API for getting all to-dos. After that, we need to create API for adding a new task. And after that, we can update the single task details. So one API for updating the task. And at the end, we need to delete single to-do. So another API for delete specific task. So currently, we know we need these 4 APIs. And we will create 2-3 extra APIs for practice. If while building project we need to create more APIs, then we will create more APIs. There is nothing wrong about that. This is just a rough plan for reduce the confusion. Now let's create a fresh application for our project. So open the folder in which you want to create project and I name it as task track. And simply open this folder in the VS Code. This is the name of our project. Is it sounds good? I hope it is. If you have better name, then you can also use it. It's totally up to you. Now what we have to do for creating Node.js applications? Do you remember? We just did that in our previous section. Yes, simply we open our terminal and initialize our project using npm init. And for all yes, we will use -y here. See, we get package.json file with some default config. Here we can see our main file is index.js, which is the file runs when we start our application. So let's create index.js file and that's it. Here in this file, we will write code for our backend. So in the previous section, we create our server using HTTP module. And the problem with the HTTP module is we have to define our different API endpoints in this if and else if statements, which is not very clear and also not easy to maintain for big projects. So that's why we use very popular package or module called Express.Js. Express.js is minimal and flexible for creating better Node applications. In simple words, by using Express.js, we can simplify our routes, we can easily handle HTTP request and response, middlewares and much more things. Let me show you something. Here is the Express package on npm.js website. We can see its weekly downloads are almost 37.2 million, which is crazy. And almost in 90% of Node.js projects, developers use Express package. So it is very important to master Express, right? First of all, let's install this module in our project. So open up terminal and write npm install express. At the time I am recording this course, its latest version is 5.1.0. If you want to get the same experience as I am getting, then you can write here npm install express @5.1.0 and hit enter. Don't worry about Express, it is really simple package. Done. And now we want to use this Express module in this index.js file. Can you tell me what we have to do? Right, we will import the Express module using require function express, and this require function returns a function. So we simply store it in variable called express. Now to create an express application, we call this express function here.
Aduh, salah.
Which returns a object, and we store it in variable called application or app. You can give it any other name, but probably all developers called it app. So let's go with app. Now in this app object, we get many useful methods. For example, we have here app.get, app.post, app.put, app.patch, app.delete, etc. Do you remember where we see these 5 methods? Right, they are HTTP methods for creating different types of API. So if we want to define our API for HTTP GET method, then we use app.get. If we want to define HTTP delete method, then we use app.delete. Same as we can create post, put and patch request. The way to define all these 5 methods are the same. Still, we will see all methods in this section one by one. For now, let's start with get request. So in this get method, at the first parameter, we have to write our API endpoint name. Suppose we want to define get API for URL http://localhost:3000/todos. Now what is our endpoint in this URL? Right, /todos is our API endpoint, and that's what we have to write here at the first parameter. Make sure we add here / first, otherwise this will not work properly. Now what if we want to define get API for URL http://localhost:3000, which is the root URL of our website. At that time, we can add here only /, which represents root endpoint. Now we have to define what will happen when our front end sends request to this endpoint. Do you remember? Let me show you. Here we pass callback function, and in this we get 2 objects, request and response. This request has all details about URL request, and with this response object we can send response related details. We already seen this in HTTP module lesson. Now what we want to send when someone sends request on this API? For now, we simply return a text response.send task track project. So when someone sends get request on this endpoint, this function will run and then it simply returns this text in response. Simple as that. So by these 2 lines, our Express server is created. But we have to run or listen this server on some port. If we don't listen our server, then our API will not work. So here at the end we write app.listen, and simply here we pass our port number, and at the second parameter we again pass callback function which will run when our server started listening on this port. So here we can simply console.log server is running or listening on this port 3000. Save the changes and let's run our index.js file. Write node index.js. See, server is listening on this port 3000. Nice. Now back to browser and run localhost colon 3000, which is the root URL, and see, here we get task track project text which we send from our server. You can see Express makes our code really simple. We can compare our current code with the previous HTTP module code. Express makes it really simple. Also, this is our first API, that's why we return only text in response. Now as we move forward in our project, real thrill will start. Now let's create API for getting all to-dos list. Can you tell me which HTTP method we have to use? Right, for getting the data from the server, we use getHTTP method. So here we write app.get, and let's say we want to give this API name to-dos. So we pass here /to-dos, and after that at the second parameter we pass callback function which has two parameters, request and response. See, for all APIs this structure will stay the same, only this HTTP method changed, this endpoint changed, and logic inside this callback function will change. That's how Express.Js makes our project simple and clean. Now currently we are not going to work with the database because we don't want to add extra complexity for our first project. We will learn all these things step by step, so don't worry about database. Now here we have to send all to-dos array. So at the top I define one dummy data called to-dos array and simply add some to-dos in this. So here every to-do is object with 4 properties. ID, let's set it to 1. Task, which is the text of task, let's say create all APIs for project 1. Tags, which are the tags related to task, which is an array, Node.js, comma, JavaScript. And status to-do. These properties ID, task, tags, status is defined by Node.js developer, which means you. What you want to call it, how many properties you need, these things you have to decide based on which data we want to store and which data we don't want. Now let's duplicate this object 2 more times using Shift plus Alt plus down arrow or Shift plus Option plus down arrow. Now we change this ID to 2, task to create API for list of all to-dos, tags, Node.js, and status to doing. And at last, we simply change ID to 3, task to plan project 1, tags, JavaScript, and status to done. Now we want to simply return this array as a response when someone sends GET request to API with /to-dos endpoint. So what we write here? Right, we write response.send and simply pass our to-dos array. Save the changes and let's verify this API is working or not. Open terminal, close the current running server using Ctrl+C and again run this file. Now in the browser, at the place of root website, we simply call /to-dos endpoint. See, here we get our array. So that's how simple to send data from the backend using GET API. Now currently, when we do some change in our project, we have to close our previous running server and restart our application, which is really annoying. So for automatically restart our application, we have one package called nodemon. It is really useful. So open up terminal and write npm install or I-G nodemon. Here we use -g for installing this nodemon package globally. Otherwise, we have to install nodemon in every node project. Also, if you are using Mac, then for installing global package, you have to write sudo at the beginning of the command and then it will ask for system password. Now how can we run file using nodemon? Let me show you. So in the terminal, previously we are running file using node index.js. Now for nodemon, we write nodemon index.js. Simple as that. See, here we get our nodemon version and for restarting, we can enter rs. Also, it is telling us watching path period, which means root of this project. After that, it is watching extensions like JS, MJS, CJS, JSON, etc. So any file which have this type of extensions, nodemon is constantly watching those files, and if something changes in those files, it will restart our application. And at the end, see, nodemon is also running command node index.js. So by using nodemon, we don't have to restart our application. It will automatically restart when we change something in those files with those extensions. Now currently, we are manually setting the port of our server, but in the real world, that port is set by environment in which our application is running. Specifically, it's managed by the hosting provider or development platforms like Render, Heroku, AWS, etc. So when we deploy our application on these platforms, our 3000 port might be already used by another server. At that time, if we hard-coded our port, then our server will not run on that port and it will give us error in the deployment. So what is the solution here? It is really simple. We will check one condition. If in our application environment port variable is defined, then we use that port variable, else we use our hard-coded port. Let me show you, it is really simple. So here, before we listen our server, we create a variable called port equals to. Now here, how can we check our server has port in its environment or not? So for that, we have one object called process.env. This env is for environment. In this environment, we get all variables which are set by hosting platforms and .port for port variable. So if any hosting platform want to set different port, then they will store them in this process.env.port variable. That's common convention. Also, all environment variable name is all capital letters, and that's why we also give this variable name as all capital port. So just by looking at it, we know it can be environment variable. Now if this process.env.port is available, then no issue. But if it is not available or set, then we have to pass our hard-coded port value. So we add here OR operator, which is bar symbol 2 times. It is the key above enter or return. And here we pass our port, which is 3000. Now let's pass this port variable at the place of this hard-coded port, and also we will change this console message. Let's make this string as template string using backticks, because in template strings we can easily access variable and change this 3000 with $curly brackets port. So if this environment port is available, then we use it, or if it is false or null, then we use this 3000 port. Simple as that. Currently, in our application, environment port is not set. That's why our application will run continuously on port 3000. Don't worry if you are little confused about this process.env. We will see it in details in the upcoming projects. Now let me give you one shortcut for setting up Node application. First, required Express, create Express application, create this port variable using this expression, and listening the Express application on the port. These four things will stay the same in all Node applications. Yes, we can add more functionality in other lines, but nothing will change in these four lines. Previously, we created API for getting the list of all to-dos in our application. But what if we need to get the information about only single to-do, like to-do with ID 1 or ID 3? For that, we need to pass ID in API URL. So our API URL look like this, /todos/1, which means we want to fetch one to-do information whose ID is 1. This type of variable which we pass in our URL is called as route parameter, and it is very important for providing the specific information about API request like ID, status, date, anything. Let me show you how we can set this type of API URL and access the route parameters. So we add new get API and endpoint to /todos/ Now here, for defining route parameter, we use colon and give our route variable name like ID. So this ID is our route parameter. We can call it anything like to-do ID, but ID is short and sweet, so we go with ID. And that's it. That's how we can define route parameter in our API URL. Now let's access this route parameter in our API logic. Again, we add here callback function with two parameters, request and response. Now inside this function, what do you think? In which object we get information about our route parameter, request or response? Right, we get information about route parameter in request. So request.params. In this params object, we will get all route parameters and we can access it by .id. See, here we get also auto suggestions. Now let's simply send this ID in our response.send. Save the changes and back to our browser. Head over to localhost :3000/todos/1 and see, here we get ID 1. So we are successfully getting the route parameter. Now here is one thing. We can also pass multiple route parameters in our API. For example, we can pass task status to do. Now in the backend, we add here route parameter. And how can we do that? Right, we add /status. And how can we access route parameter? Right, we use request.params.status. Let me show you whole route params object. Save the changes and back to browser. We pass here status value after our ID value. Make sure the order is the same as we defined in our API, which means first ID and then status. See, here we get the params object with those two properties which we defined in API. Now you might have curiosity, what if we don't pass here status? Let's also see that. Remove the status value and see, here we get cannot get /todos/1, which means our server didn't found API with this URL. So if we define route parameters in our API, then make sure we will pass all route parameters in right order. Now there is another way to pass data in URL, which is by using query parameters. If you are using websites, then in URL you might see question mark and then pass some types of variables like short equals to date and order equals to ASC for ascending, etc. These are the query parameters which is used for passing data in URL. Now you might ask, what is the difference between route parameters and query parameters? Both are used to pass data in URL, but route parameters are used to pass data which is most required, where query parameters are used to pass data which are additional or optional. In simple words, in our API, if frontend didn't pass route parameters, then our API will give us error. But if we didn't pass query parameters, then our API will not give us error. It is an additional details. In our example, if we didn't pass to-do ID or status, then it will give us error that API not found. But if we don't pass these variables after the question mark, then we don't get error. Now let me show you how we can access these query parameters in our API. So for that, we don't need to change anything in the API URL. We can directly access them in our callback function. So for query parameter, we have another object in request, which is request.query. And that's it. We don't need to do anything in our endpoint. Save the changes and take a look. See, here we get the query object. So request.params is used for route parameters and request.query is used for query parameters. We will use them a lot when we build complex APIs. They are very useful. Now let's see how we can return single to-do by its ID. So for that, what we use? Route parameter or query parameter? Right, we will use route parameter because that information is most required. So we remove this slash status from our endpoint, we don't need it. And in the callback function, we need to return the single to-do which ID is the same as our route parameter ID. First of all, let's store the route parameter in separate variable. So const to-do ID equals to, how can we access route parameters? Right, request.params.id. Now we have to find the single to-do from our to-dos array which ID is same as this to-do ID. For that, we use one JavaScript array method which is find. So to-dos array dot find, and inside this find method, we pass callback function, and here in the parameter, we get the single to-do object as t. So this t is this single object in the to-dos array. And we return here condition if t.id equals to our to-do id. If you don't know this find method, then let me explain you in short because it is pure JavaScript concept. So this find method will check our to-dos array, and first it will pick the first object of the array in this t variable. Then we check the condition t.id is same as our to-do id. If it is true, then this find method will return that single object. So we store in variable const to-do. And also, if this condition is not satisfied, then it will set t as next object and then again check the condition. And that's how we can find single to-do using this find method. Let's also send this to-do in response.send method. Save the changes and take a look. Let's remove these query parameters and also status value. And here we don't get anything. Why? We pass id 1 and in our to-dos array, we also have to-do with id 1. Then what is wrong? Let's try to console this single to-do. Save the changes and refresh the page on browser. Now in our VS Code terminal, where we are running our server, we get our consoles. See, here we get undefined. So we cannot find to-do from our to-dos array, and that's the error. May this error occur because we are not comparing the IDs properly. Let's also try to console this to-do ID type using type of to-do ID. This will return the type of to-do ID. Save the changes and refresh the page. Back to VS Code and see, here we get undefined for single to-do and we get type string for to-do ID. And that's why we are not getting single to-do, because here our to-do ID is integer and we are comparing it with the string. So we have to convert this to-do ID string into integer. So we can wrap this request.params.id with parse integer. This parse integer function will convert our string into integer. Save the changes and take a look. Refresh the page and see, here we get the single to-do object with ID 1. If we pass here ID 3, then we get here to-do with ID 3. So it's working. Good. Now you might ask, in the route parameter, we are passing 1 as integer. But why in the backend we get it as a string? So the truth is, whatever we pass in the URL, it is passed as string. So if we want to pass something as integer, then we have to convert it in the backend. We can't pass integer value using route parameter, and it is also true for query parameters. So always remember, when you define route parameters or query parameters, then you have to convert its value using parse integer or parse float method. I intentionally create this error to show you what might happen when we create API and access ID in the route parameter. Now let's create post API for adding a new to-do object. So as we know, for creating new data on server, we use post API. And also in post request, frontend will send data to the server. For example, here we create post API for adding a new to-do. So our frontend will send details about the to-dos like task, tags, and status in the body of that request. Without this information, how can we add new to-do in our to-dos array, right? Don't worry, let me show you this practically. So here we define post API using app.post, and at the first argument we pass our endpoint. Let's pass /todos, and at the second argument we pass callback function with two parameters, request and response. Now you might ask, these two endpoints are same. How can we use these APIs individually? So here we can see this API used get method, and this second API is used post method. So when frontend send API request on this endpoint with get method, this function will run, and if frontend send API request on this same endpoint with post method, then this function will run. We will see how to send post request in just a minute. Now, as we know, from frontend, we send data in the request body. And how can we get information related to request in this function? Right, we can use this request parameter. In this request, we will get all information about that particular request. So here we have request, and in this request, we have property called body. This body has all data which frontend sends with the request, which is our to-do object. So we store it in variable called to-do. And after that, simply console.log this to-do. And also response.send this to-do. Now let's test we are getting data in our to-do variable or not. Previously, we are sending simple get request from the browser URL. Because by default, browser send get request to the URL, but we cannot send other HTTP requests using browser URL. For that, we need front-end code, or we can use API testing software like Postman, or we can also use one VS Code extension called Thunder Client. From these three options, installing VS Code extension is much easier setup. So in this course, most probably we will use Thunder Client and Postman both, because for testing advanced API we need Postman. But don't worry, both interfaces are same. Main thing is we should able to test our API. Simple as that. So head over to extensions panel from here and search Thunder Client and install it. Now in our panel list, this Thunder Client icon is added. So let's open it, and here we can test our APIs for our project. So first of all, we enter our API URL, which is http://localhost:3000/todos. And which method we need? We need post method. So we select post from here, and now we have to pass to do object in our request body. So for that we select here body, and in the JSON option here we will pass our data in object. First field we need is task. So we have to pass field name in double quotes, and also we have to pass value in double quotes. This is new task. Also, if you can't see these fields properly, then close this panel by using Ctrl+B or Command+B. After that, we need another field which is tags, and we pass here array, and in that we pass two values, HTML and CSS. And last field, status, and value, let's say to do. Now here is one thing, this field name, which is this task, tags, status, these names are set by the backend developer. Whatever name backend developer define, frontend developer should send data with the same field name. Otherwise, how in the backend we fetch data from the body of the request. Now for sending this post request, we click on the send button. See, we didn't get anything. And if we check our terminal, then also we get undefined. So why we are not getting the data in our request.body object? What we are doing wrong? So when frontend sends post request, it sends data in the body of the request in JSON format. And that's what we also did in our testing request. Now by default, Express server does not know how to automatically read and understand that JSON data. So for Express, we need a translator which will convert that JSON data in a simple JavaScript object. Because we cannot directly work with JSON data, we need to convert it in object or array which our JavaScript can understand, right? So for that, we have one middleware in Express which will work as a translator. So after this to-dos array variable, we add app.use, and in that we call our middleware Express.Json, and that's it. Make sure you add this middleware before our APIs, and also you have to call this Express.Json middleware, otherwise it will not work. So currently, without this Express.Json middleware, we are getting request.body as undefined. Now let's save the changes and again send post request. See, now we get our request.body same as we send this object. So this is the importance of Express.Json middleware. Now we have to just add this new to-do in our to-dos array. So we use here simple array method to-dos array.push. This will add new data at the last position of the array. And here in the push method, we pass object because all our to-dos is in object, and we have to follow the same object structure for the new to-do. So first of all, we need ID. And how can we get the ID? We didn't pass it from the front end. So for ID, we can do something like this. We will get the last to-do ID and increase it by 1. So to get the last to-do of the list, we write to-dos array in square bracket to-dos array dot length, which is currently 3, but we know array index start with 0. So we have to do here length minus 1. So this to-dos array in square bracket to-dos array dot length minus 1 is our last to-do object, and we want to access its ID. So we add here dot ID and simply increase it by 1. So if our array length is 3, then 3 minus 1, which is 2, which is the index of the last element, and then we access its ID and increase it by 1, which is 4. Simple as that. Next, we have task field, and we pass value as to do, which we get from request.body, and for accessing task, we add .task. Next, we have tags, and we pass value to do.tags. And last, we have status, which is what? Right, to do.status. Now I think this might confuse you. So we define this new to do object separately. So const new to do equals to paste this object here. And in the push method, we simply add this new to do. I think this looks more clear. Also, one thing I want to tell you, in any API at the end of the callback function, we must add response.send. Otherwise, on our front end, our request keeps running and that's make our overall speed down. So make sure in every API we return something. Now you might ask, what should we return from the post request? So from the post request, we can return recently added data in our server or database. So our front end gets all the information like ID and use them as they want. So here we simply return this new to do, save the changes and take a look. Send the request again and see, now we are getting data with ID 4. And if we fetch all to-dos from the get request, then see, we get 4 to-dos. So we successfully create post request and add new to-do in our to-dos array. Let's quickly recap what we learned in this lesson. So we use post request for create a new data on the server, and we get that new data from the body of the post request sent by frontend. For testing that, we use this Thunder client extension and send our data in JSON format, which is the common format for sending data. Now in the backend, we need to convert that data into simple JavaScript format, and that's why we use Express.Js middleware and add it before our APIs. Without this Express.Js middleware, we are getting request.body as undefined. After that, we add the new data in separate object with its all field and then simply push it in the to-dos array. And at the end, return the new added data from response.send. Simple as that. Now in the next lesson, we will improve this post request. Now currently, our front end is sending whatever data they want to send. But what if someone don't send the required data like task tags or tags array or status? Without them, we can't add incomplete data in our storage. It's bad for our application. So in that condition, we have to add data validation in our API. So at the beginning of our API, we will check frontend is passing all the necessary data or not. If it is not passing proper data, then we stop that request immediately with proper error message. Let me show you what I mean. So here, after we are getting the data from the request.body, we add simple condition if todo.task is not available, then we return error from here. So in the curly brackets, we write response.send task is required. Now here is the one thing. Even if we write here response.send, our remaining code will also work. So to stop running the code from here, we have to add here return. Without this return, our remaining code will anyway run. So don't forget to add return. Now let's duplicate this if block 2 more times using shift plus alter plus down arrow or shift plus option plus down arrow. Now we simply change the condition for tags to do.tags and change the error message tags are required. And at last to do.status and status is required. Also, here we can check more conditions like tags should be array or task value should more than 3 characters, etc. For now, we don't want that complexity, so let's test this implementation. Save the changes, open the post test, and we simply remove this task field. Send the request, and see, here we are getting this message, task is required. Beautiful. Now front end just need to display this error message on the form or anywhere they want to display. So by this way, we can manually validate our input fields data. But these are only 3 fields. Imagine we have 7 to 8 fields and for each field we want to validate data. Then we have to write this if condition 7 to 8 times. So is there any other way to do that? Yes, we have special library for validating the user data. First one is Joy. This is one of the most popular and robust data validation library in Node.js. And we will also use Joy for data validation in this course. Also, there are another library like Yup and Validator.js. You can use any of this library. I personally like Joy and we will use Joy in the next project. Currently, our main focus is on creating CRUD APIs, which means create, read, update, delete APIs. Now when we return an error from the server, it's better we also pass the error code with that error message. By that error or status code, our front end gets information about the success or failure of the HTTP request. You might already know about this or you might seen this error. For example, when we don't found a web page, some website display 404 not found page. This 404 is the error or status code for not found. Let's see most common error or status code for HTTP request. So first one is 200, which means all okay. This is the default status code which sent by our Express application. And in our request also, we can see here we are getting status 200 okay. Next we have 201 code, which means created successfully. So if we create a new data on our server, then we can return that data with status code 201. Can you tell in which HTTP method we can return status code 201? Right, in the post request if our data is successfully created. Next, we have status 400, which means bad request done by frontend. These include some missing or invalid or unauthorized access request. And yes, for data validation, we will return error message with this 400 status code. Next, we have 404, which means not found. Suppose we are sending GET request for getting the single to do with ID 10. Now that is not available in our data. So at that time, we can send response with 404 status code. Another important status code is 500, which means internal server error. Suppose we get some error in creating the new to-do on the server. Then at that time, we will return response with status code 500. There are many status code, but for now, these are most useful. Don't worry, with practice, you will remember all those status code. Now for passing the status code with our response, we can add here multiple cursor. So press Alt or Option and simply click where we want multiple cursor. And here we add .status, and in this with status code we want to pass for invalid data. We pass 400 and that's it. Press Escape for remove multiple cursor, and that's how we can pass status code with our request. Also, if we successfully create data, then we return response with status 201. Save the changes and take a look. Send the request again and see, here we get error status code 400 bad request. Lovely. Now till now, we are sending the response using response.send method. But this response.send method is used for general purpose, which means in this response.send method, we can send any type of content like plain text, HTML, or we can also pass JSON data. Now when we create API in Node, most of the time we want to return data in the JSON format because it is much easier to handle. So here in the response, we have another method called response.json. This will automatically convert our data in the JSON format, and also it will set header content type to application/JSON. Don't worry if you don't know about header content type, we will see that in the next section. So we will use response.send for simple responses, whether text, HTML or objects, and we will use response.json when we want to ensure that the response is in JSON format and properly formatted for JSON clients. Both works almost the same, but for JSON data, response.json is more convenient. So in the first GET request, we want to send the plain text. So we use here response.send. After that, we want to send to do array. So we can use here response.json. Next, also we want to send object, then what we will use? Right, we use response.json. And let's also remove this console. We don't need consoles in our server. It is just for testing. Next, here we are returning error. First, we change this send with JSON, JSON and JSON. And it's better we pass that error in object. So wrap this string in object and simply add here message property and colon. Same we do for this error and also for this last error. And when we successfully creating a new to-do, then we are returning the new to-do object. So we also change this send with JSON. Make sure you don't pass plain text in the response.json method. It will give you error. Save the changes and in the previous testing, go to the header section. Here we get bunch of details, but for now we need this content type. See, it is set to text/HTML. Now let's send another invalid post request. See, here we get the object which we send with message property. And now if we check our content type, see, it is set to JSON. So use response.send for plain text or HTML and use response.json for sending JSON data. Now let's create an API for updating our single to-do. Suppose we want to update text of task or we want to update the status. So here we want to update little details about our current data, or we can also update all the informations. So it's better we use here put request. Also you can use here patch method, it's totally fine. So app.put endpoint to/todos. Now here we need the to-do ID which we want to update. So we add here route parameter :id. After that, we add callback function with request and response. Now first of all, let's get the id parameter. So const id equals to request.params.id. And we know that this id is string. So we wrap it with parse integer function. Now our first task is we have to find which element of the array has this id. And then by that element index, we can change other values very easily. So for finding the index, we use todos array.findIndex method. Here we get single to-do object in this t and then we pass condition t.id should equals to our id parameter. This expression returns the index of the element. So we store it in variable called toDoIndex. Now what if user pass id which is not available in our array? At that time, this toDoIndex value will become -1 because this findIndex method returns -1 if we don't found the toDoIndex. So here we pass if condition toDoIndex is equals to -1. Then we return response.status 404 which is not found and then .json and we send object with property message and simply return here message to-do not found. Make sure you add here this return. Great. Now suppose we found the to-do index, then we have to update that element fields with our new data passed with API request. So at the top, first we get data from request.body and store that object in to-do variable. Now instead of defining three different variables, we can use here object destructuring. So at the place of variable name, we can simply add curly brackets and write our property names which passed in the request.body. So first we get task, then tags, and then status. And that's it. This single line of code works the same as these three lines of code. Now in the update, not every time we change task or we only change status, we can change any of these three properties. And our front end should pass only those properties in the body of the request which they want to change. So here we can do something like this. If task is available, then we update to-dos array to-do index dot task is equal to task. So if this task is available in the body request, only then this line will update the task property. Let's duplicate this if condition 2 more times. Let's replace this task with tags, tags, and tags. Also, this one status, status, here also status, and that's it. Also, here we are missing one thing. Can you tell me? Right, we have to return response at the end of this function. So response.json, and here we send our updated to-do object. So to-dos array in square bracket to-do index. Save the changes and let's test this implementation. So go to Thunder client and create a new request. Write our endpoint which is http localhost 3000 /todos/. Here we pass to-do ID, let's say 1. Change this get method to put method and let's pass data in the request body, object with property task and value to this is the updated task and simply send the request. See, here we getting the updated data, and if we pass here ID 10 and send the request, then we get here error message not found. You can see how simple it is to create API. Also, if you want to save your test, then press Ctrl+S or Command+S, and then from here we can also rename our test request update to. Now it is time for interesting exercise. You have to create API for deleting the specific to-do using its ID. This is a lot easy exercise. Exercise will help you to learn fast and also boost your confidence. And even if you can't complete the whole exercise, at least try to solve it, because that's how you know on which part you have to work more. So give it a try and then watch the solution. So I hope you solve this exercise, or at least try to solve it. Now let's quickly see the solution. So here we define a new API using app.delete because we are deleting data here. Endpoint /todos /ID callback request response and arrow function. Now first of all we get the ID from the route parameter. So const ID equals to request.params.id and simply wrap it with parse integer function. This parse integer practice is very useful because when I am learning Node.js, this one mistake I repeat a lot. So make sure you don't repeat this mistake. Now here also, first we have to find the index of the to-do object which has this ID. So from the put method, we copy this variable line and also we copy this condition for not found and paste them in our delete method. Now after that, we have to simply remove that specific to-do from our to-dos array. So for that, we use to-dos array.splice method. In this, we have to pass two arguments. First, which index we want to remove, which is this to-do index. And second argument, is how many elements we want to remove from this index. Suppose we have index value 2 and here we pass 3. So this splice method will remove 3 elements with the index 2 and also it will remove the element with index 3 and 4. In our case, we just want to remove this single element. So we pass here 1 and at the end we simply return response.json and here we pass success message. So object with message property and value to do deleted successfully. Save the changes and let's also test this delete request. Create a new request, change the URL to http://localhost:3000/todos/ let's delete the task with ID 1. Select delete method and here we don't want to pass anything in our request body. So send this request. See, here we get success message which means our task 1 is removed from our to-dos array. Now if we again send the request with the same ID, see, here we get not found. Lovely. You can see creating APIs is not that much difficult. And in this section, we created get, post, put, delete, all CRUD APIs. So I hope you understand how to use Express and create REST APIs with Express. Now in the next section, we will learn some advanced concepts of Express. So see you in the next section.